What if the survival of humanity depended not on Earth, but on a frozen moon nearly 400 million miles away? Could you imagine living on a world where the oceans are trapped beneath miles of ice, and sunlight is only a distant glow in the sky? How would it feel to know that, in the year 2200, you might be one of the first humans to call such a place home? Europa isn't just a destination, it's a new frontier where the impossible becomes reality. But, is it really where humanity's future lies? Alright, so let's talk about Europa. Of all the places in the solar system, why this tiny frozen moon orbiting Jupiter? Why not Mars or Titan, or even the moon we're already mining? The truth is, Europa is unlike any other world we've considered. Sure, it looks like a block of ice from a distance, but beneath that cold, thick surface lies something extraordinary. A vast ocean. And this isn't just any ocean, it's potentially deeper than all the oceans on Earth combined. Now think about that for a second. We're talking about a hidden ocean that could hold the key to life, locked beneath ice that's been there for billions of years. It's mind-blowing, right? Europa's ice is like a protective shield, hiding secrets that have been waiting for us to discover. But there's more. The gravitational pull of Jupiter causes tidal forces, heating up Europa from the inside. So, despite the freezing surface, there's warmth beneath that ice. Liquid water. Possibly even geothermal activity. In other words, conditions that are just perfect for life, or at least life as we understand it. And that's what makes Europa so special. It's not just another chunk of rock in space, it's a place that might actually have, or be able to support life. Imagine being part of the team that could finally answer one of humanity's oldest questions. Are we alone in the universe? Europa offers us a chance to find out. But there's another reason we're so drawn to it. For all its icy mystery, Europa also represents a new kind of frontier, a place where we could build something completely new, beyond Earth, beyond Mars, in a whole new part of the solar system, and maybe, just maybe, it's where humanity could make its greatest leap forward. That's the promise of Europa. It's not just a moon we're going to explore, it's the next chapter of human civilization, waiting to be written. Alright, so now that we've covered why Europa is such an exciting destination, let's take a step back and talk about how we're even able to get there. You might be wondering, with all the advancements we've made by 2200, why we haven't already set off to every corner of the solar system. Well, the truth is, space travel is still incredibly resource intensive. And that's where the moon, our moon, comes in. By the year 2200, the moon isn't just some barren rock in the night sky anymore. It's become our stepping stone, literally and figuratively. See, we're not just mining the moon for fun, or because we're curious. We're mining it because it's packed with resources that we desperately need for deep space travel, especially something called helium-3. This isotope is pretty rare on Earth, but the moon, it's full of it. And helium-3 is a game changer because it powers fusion reactors, our primary energy source for long-range spacecraft by now. Imagine this. Instead of being limited by traditional fuel that runs out in weeks or months, you've got a power source that can last for years. We're talking fusion energy that makes deep space travel not only possible but sustainable. Without it, the journey to Europa would be, well, let's just say it'd be a lot more challenging. But it's not just about the fuel. The moon is also where we've established massive manufacturing operations. Materials mined on the moon, metals, minerals, are being used to build the spacecraft that will take us to places like Europa. Think about that for a second. We're no longer reliant on Earth's limited resources. By the time we launch a mission to Europa, nearly everything we need, our ships, our energy, even parts of our habitats, are sourced from the moon. That's a huge shift in how we explore space, and it gets even better. By building and launching from the moon instead of Earth, we avoid dealing with Earth's heavy gravity, which makes space travel far more efficient. In other words, the moon has become our spaceport for the solar system. And that's what makes this whole mission to Europa possible. It's not just about advanced technology, it's about using the resources of space to conquer space. But of course, even with moon mining and fusion energy, the journey to Europa isn't a short one. We're talking millions of miles and months in deep space. So what does it actually feel like to travel that far? So, we've got the moon mining operations in full swing, we've cracked the code on fusion energy, and we're ready to take off. But let's talk about what it actually takes to prepare for a mission like this. Because sending a crew to Europa is not as simple as just building a ship and launching it. This is a mission that requires precision, dedication, and some pretty wild technology. First off, the spacecraft. By 2200, our ships are nothing like what you'd think of today. We're talking about massive, self-sustaining vessels that are essentially small cities in space. These ships are equipped with artificial gravity, advanced life support systems, and of course, fusion reactors to power the entire journey. But it's not just the tech that's impressive, it's the scale. This isn't a crew of just 5 or 6 astronauts. We're sending dozens of specialists, engineers, biologists, geologists, and yeah, even a few people whose sole job is to make sure everyone stays sane during the long trip. Now imagine being part of that crew. Months of preparation, training in low gravity, learning how to operate the spacecraft's systems, running simulations of every possible thing that could go wrong. Because let's face it, in deep space, you've got to be ready for anything. There's no calling home for help. You're on your own out there. And here's the thing, these missions aren't just about survival, they're about thriving. By this point, we've developed all kinds of tech to make sure life on the ship is as comfortable as possible. We're talking about food that's grown right on board, using hydroponics and even bioreactors that recycle everything. Yep, everything. It's a closed-loop system where waste is turned back into energy and resources. Pretty futuristic, right? But on a mission this long, there's no room for waste, literally and figuratively. Then there's the mental side of things. How do you prepare for a journey that could take over a year, where you're stuck with the same people day in and day out with nothing but the stars around you? This isn't just about technical skills, it's about emotional endurance. The crew has to train for isolation, learn how to deal with conflict, and even practice ways to keep their minds sharp. Think of it like preparing for a marathon, except the finish line is over 390 million miles away. And the launch itself? That's an event like no other. Imagine standing on the lunar surface watching your ship slowly rise off the ground, not with a roar of engines like the rockets of the past, but with the silent, steady power of fusion energy. No giant clouds of smoke, just a quiet, controlled ascent. The moon's low gravity makes the launch feel almost peaceful. Until of course you're speeding away from the moon, watching it shrink into the distance, knowing that your destination is Europa. But what's it really like once you're out there, far away from everything familiar? Well, life in deep space is a whole different story. So here we are. The ship is ready, the crew is trained, and we've said our goodbyes to Earth, or in this case, the moon. Now imagine yourself strapped into one of the most advanced spacecraft humanity has ever built, about to leave everything behind. There's a strange feeling in the air, right? A mix of excitement, a bit of fear, and that overwhelming sense of stepping into the unknown. The countdown starts. But unlike the loud, fiery launches we're used to seeing from Earth's past, this one is different. The ship lifts off from the moon almost silently, the fusion engines smoothly propelling us into the dark of space. You watch as the lunar surface gets smaller and smaller until it's just a speck in the distance. In minutes, you're out of the moon's gravitational pull, and the real journey begins. Now what's it actually like on board? It's surreal. One minute you're on the lunar base with familiar surroundings and solid ground beneath your feet. The next you're weightless, floating through the corridors of a massive ship, surrounded by nothing but the stars. The ship itself is designed for long-distance travel with artificial gravity in most areas, so you won't be floating forever, but those early moments are a real trip. The crew, everyone's buzzing with energy. For some it's their first time in deep space and you can see it in their eyes, the thrill of heading into the unknown. For others, the veterans, it's just another mission, but even they can't hide their excitement. Because this isn't just any mission, it's Europa, and even the most seasoned space travelers have never been this far. Of course, once the adrenaline wears off, the reality of the journey sets in. Months of travel ahead with nothing but the vast emptiness of space around you. It's a strange feeling being so far from anything familiar, and while the ship's technology is advanced enough to simulate a lot of comforts, from artificial gravity to hydroponic food systems, it's still space. The isolation, the distance, it's all very real. And what's crazy is how quickly space becomes normal. After the first few days, you adjust to the routine. Everyone's got their role on board, whether it's monitoring the ship's systems, conducting experiments, or just keeping everyone mentally sharp. And that's when you realize something: space isn't just a place you visit, it becomes your home. It's not just a void to cross to get to Europa, it's the environment you live in and day out. But of course, deep space isn't without its challenges. There's no weather, no seasons, no day or night. You lose track of time. The crew relies on the ship's internal clocks to stay synced, but it's easy to forget what time even means out here. Imagine waking up, and it's nowhere. No sunrise, no sunset, just the distant glow of stars and planets that are so far away, they almost don't seem real. And yet, for all its emptiness, space has a kind of beauty. The view from the ship's observation deck is breathtaking. An endless sea of stars, with the occasional distant planet or asteroid slowly drifting by. You can see Jupiter getting closer each day, its massive bands of gas slowly coming into view. It's hard not to feel small out here, but at the same time there's a sense of awe. You're part of something bigger. You're on a journey that humanity has only dreamed about for centuries. So you're out in deep space now, millions of miles from the moon, heading toward Jupiter. At first, everything feels new and exciting. But then, as the days turn into weeks and weeks into months, the reality of life in transit starts to settle in. You've got a long way to go, and the days start to blend together. Now, living on a spacecraft isn't exactly like life on Earth, but it's not the sterile, cramped existence you might picture. The ship is designed for long-haul travel, so there's space, actual space, to move around. You've got common areas, sleeping quarters, even a kind of garden where plants are grown hydroponically. It's not just for food either. The plants help purify the air, and honestly, having some green around does wonders for your mental health. But no matter how well designed the ship is, there's no getting around the fact that you're in a confined environment for a really long time. You start to notice the little things, the hum of the engines, the way the walls never change, how there's no real night or day. The ship's artificial gravity keeps things feeling somewhat normal, but there's always that underlying awareness that you're not on solid ground. And then there's the crew. At first, everyone is buzzing with excitement, talking about Europa, speculating on what they might find. But after a while, those conversations start to slow down. You fall into routines. Each person has their job: pilots, engineers, scientists, even the psychologists monitoring the mental health of the crew. But even with those roles, the monotony of deep space can get to you. Some crew members find solace in their work, diving deep into research or maintaining the ship. Others turn to more creative outlets, writing, painting, even building models. Anything to keep their minds occupied. Social dynamics become important too. You can't just walk away from someone you don't get along with in deep space. You're stuck together, so conflict resolution becomes critical. The crew had extensive training in how to deal with interpersonal issues before the launch, but still, after months of close quarters, little things can turn into big annoyances. A crewmate leaves their tools out, someone's too loud when others are trying to rest. Small stuff. But out here, small stuff can become big quickly. So the crew has to stay focused on the mission and be mindful of each other's space, both physically and emotionally. Then there's the mental side of things. Isolation in space is unlike anything else. You're far beyond the reach of Earth. Even with all the technology, the video calls, the virtual reality rooms that simulate Earth-like environments, it's not the same. You can't really escape the fact that you're on a ship, surrounded by nothing but the infinite void of space. That can mess with your head if you're not prepared for it. Exercise becomes a huge part of daily life. The crew uses specialized equipment to keep their bodies strong in the artificial gravity. Not just to stay fit, but because long periods in space can weaken muscles and bones. So everyone follows a strict regimen to make sure they're in peak condition by the time they arrive at Europa. Plus, let's be real, working out is one of the best ways to break the monotony. It gives you structure, a goal, something to focus on. Entertainment is key too. The crew's got access to pretty much every form of media you can imagine. Movies, music, books, even multiplayer games that they can play with each other or people back on Earth. And you'd be surprised how much bonding happens over things like movie nights. There's something comforting about sitting down with your crewmates, watching an old classic, and forgetting, even just for a moment, that you're light years away from home. But then there's the flip side, moments of real isolation, where you realize just how far you've come. You look out the observation windows, and all you see is the blackness of space, dotted with distant stars.
Earth is just a memory by now, a pale blue dot you left behind. The only real constant is the ship and your crew. It's a strange mix of comfort and confinement. You're safe inside this metal shell, but also, you're in the middle of nowhere. That's the reality of deep space. And yet, through all of this, the routines, the isolation, the endless void, there's still that shared goal, Europa. Everything points to that. It keeps everyone motivated, knowing that this long, sometimes monotonous journey is leading to something incredible. But even on the most well-prepared missions, challenges come up. So, by now, the crew is deep into the journey. They've settled into routines, made peace with the isolation, and started to find their rhythm. But here's the thing about space. Just when you think you've got it all figured out, it throws something unexpected at you. Because as advanced as our technology has become by 2200, space is still unpredictable. Let's talk about one of the first big challenges, radiation. Out in deep space, you're no longer protected by Earth's magnetic field. And while the ship has shielding, there's always the risk of solar storms or cosmic rays. These aren't things you can see or feel, but they're there, lurking in the background. The crew is constantly monitoring radiation levels, adjusting course if needed, and even retreating to specially shielded areas of the ship during high radiation events. It's a strange reality, being vulnerable to something so invisible yet so dangerous. The crew wears radiation badges that change color if the levels get too high. Imagine that. Your safety depends on a tiny piece of tech that tells you if the environment around you is slowly becoming deadly. Then there's the constant maintenance of the ship itself. Even though we're in the 23rd century, things still break down. A valve stops working, a sensor malfunctions, or worse, a critical system goes offline. And out here, there's no help coming. The crew has to fix everything themselves. They've trained for this, of course, but in the middle of deep space, knowing that the ship is your only lifeline, that adds a whole new layer of pressure. One loose bolt, one misaligned piece of machinery, and you've got a serious problem on your hands. And then, there are the little things that you wouldn't even think about, like space dust. Yeah, space dust. Tiny particles moving at insane speeds. Out here, even a grain of sand could cause serious damage if it hits the ship. The crew monitors this constantly, using advanced sensors to detect any incoming debris, but it's always in the back of their minds. What if something gets through? What if there's an impact? Even the best shielding can't make you completely safe. So, there's always that tension, that awareness that danger could come from the smallest, most unexpected places. But it's not just the physical challenges. The mental strain of deep space is real, and it builds up over time. Remember, these people have been in space for months now. They've been working together, living together, day in and day out. Cabin fever starts to creep in. Even with all the mental training, even with virtual reality to escape into, you can only simulate Earth so much. Some crew members start having vivid dreams about Earth, about grass, oceans, blue skies, and waking up to the same steel walls every day can feel suffocating. One of the biggest challenges? Communication delays. At this distance from Earth, real-time communication is a thing of the past. Conversations with mission control are delayed by minutes, sometimes more. That means decisions have to be made on the ship, without waiting for advice or guidance from Earth. It's empowering, sure, but it's also nerve-wracking. Every choice feels heavier, because the consequences are yours to face alone. It's like living in a time bubble, cut off from the rest of humanity. And then sometimes, there's the unexpected. A sudden systems malfunction, an asteroid that wasn't detected in time, a health scare among the crew. These moments test everyone, pushing their training, their patience, their limits. Space has a way of reminding you that no matter how advanced you are, it's still the ultimate frontier. The ship's medical officer has to be prepared for anything, from a minor injury to a full-blown medical emergency, with no chance of evacuation or immediate help. It's up to them to keep everyone healthy and safe. But here's the thing, despite all these challenges, there's something that keeps everyone going. It's that sense of purpose, that shared goal, Europa. Even when things get tough, the thought of stepping onto a new world, Of being the first humans to set foot on a frozen moon billions of miles from home, that dream is what pulls everyone through. Because let's be honest, the journey isn't just about getting there. It's about pushing the limits of what we think we're capable of. And even with all the challenges, setbacks, and unexpected surprises, the crew knows one thing: they're making history. Alright, so after months of floating through the silent expanse of space, the crew is finally approaching Jupiter. And let me tell you, seeing the giant gas giant up close is something else. As they near, the ship's observation deck offers a breathtaking view. Jupiter's swirling clouds of orange, white, and deep red create a tapestry that shifts and changes with every moment. It's hard to fathom that this massive planet, with its magnetic storms and dozens of moons, is just a speck of what lies beyond. Now let's talk about what makes approaching Jupiter such a crucial part of this journey. The giant planet isn't just eye candy, it's a critical waypoint for the mission. This is where the crew needs to perform a maneuver called a gravitational assist. It's like a slingshot effect, using Jupiter's immense gravity to propel them towards Europa. The physics behind it can be a bit mind-boggling, but essentially they're going to get a boost in speed without using up a ton of their fuel. The crew has been preparing for this maneuver for weeks, running simulations and adjusting their flight path to make sure they hit the sweet spot. You can feel the anticipation in the air as they get closer to the planet. It's a blend of excitement and nerves, because one little miscalculation could mean a major setback. This is a moment that requires absolute precision. And there's another layer to this approach. Jupiter has a radiation belt that is notoriously dangerous. As the ship gets closer, the crew must monitor radiation levels closely. They have to time their slingshot maneuver perfectly, ensuring they minimize their exposure. The ship has been equipped with advanced radiation shielding, but even so, every minute counts. As they get into position, the crew gathers in the control room. It's a scene you'd expect from a movie. The room is buzzing with energy, everyone focused on their screens, eyes darting back and forth, fingers flying over keyboards. The tension is palpable. It's like being at the edge of a high-stakes game where everything hinges on your next move. The moment of the gravitational assist finally arrives. You can almost feel the ship vibrate with the energy of the engines as they make the burn. The crew glued to their monitors, watching as they're pulled in by Jupiter's gravity. And then, it happens. A sudden jolt, a sharp turn, and the ship is catapulted forward, hurtling away from the planet. The thrill of that moment is indescribable. It's a rush like no other. And just when they think they're in the clear, they get a real-time view of the turbulence around Jupiter. The stormy clouds are mesmerizing, but they're also a reminder of the chaotic nature of the universe. Out there, you're just a tiny speck in the grand scheme of things. It's both humbling and exhilarating, this realization that they're venturing into the unknown. As the ship speeds away from Jupiter, the crew feels a wave of relief wash over them. They did it. They successfully executed the maneuver and are now on course for Europa. But the journey isn't over yet. There are still challenges ahead, and as they continue, they realize they must remain vigilant. As they approach Europa, anticipation builds. The crew is finally going to get a chance to see this icy moon up close. But they also know that the unknowns of Europa itself present their own set of challenges. What will they find there? Will they encounter the unexpected? There's no telling what might happen once they get there, but one thing is for sure. Everyone's excitement is reaching a fever pitch. Now, they're not just a group of people on a mission, they're explorers, pioneers. They're on the brink of discovering new worlds and expanding humanity's horizons. It's the kind of journey that changes people forever. And as they prepare for the next leg of their adventure, they can feel the weight of history on their shoulders. But before they can step foot on Europa, there are a few more hurdles to clear. As the ship glides through the darkness, the crew can hardly contain their excitement. After months of travel and challenges, they're finally on the brink of something extraordinary, arriving at Europa. You can feel the energy in the control room as the ship approaches the icy surface, and everyone's eyes are glued to the monitors, showing the first images of this mysterious moon. When the initial views of Europa come into focus, it's breathtaking. The surface is a brilliant white, with dark streaks and cracks crisscrossing the landscape, evidence of the tidal forces from Jupiter pulling and stretching the ice. It's mesmerizing, almost like staring at an abstract painting, and beneath that icy shell, scientists believe there's an ocean, possibly teeming with life. Can you imagine that? A hidden world beneath the ice waiting for them to uncover its secrets. As they prepare for the descent, the crew runs through final checks. The landing will be delicate, they have to avoid any potential hazards on the surface. You can sense the gravity of the moment. Everyone is acutely aware that they are making history, becoming the first humans to set foot on this alien world. That weight hangs in the air, creating an electric atmosphere of anticipation. The pilot starts to bring the ship down, and the engines roar to life, creating vibrations that run through the hull. The ship maneuvers carefully, gliding through the thin atmosphere. It's a surreal experience watching Europa grow larger and larger outside the observation windows, the landscape shifting with every moment. Everyone is holding their breath as they approach the landing zone, a relatively flat area identified in previous surveys. And then, with a gentle thud, the ship lands. There's a brief moment of silence before the control room erupts into cheers. They did it! They've touched down on Europa! Everyone hugs, high-fives, and shares smiles that stretch from ear to ear. But they know this is just the beginning. The real adventure is about to unfold. After the initial celebration, it's time for business. They have to suit up for the first EVA, extravehicular activity. Stepping out of the ship onto an alien world is a monumental moment, but first, safety comes first. The crew checks their gear, making sure every system is functioning correctly. They've trained for this, but there's something different about the anticipation of actually stepping onto the surface of Europa. Finally, the airlock hisses open, and the crew steps out into the unknown. The first crew member out takes a deep breath, and you can practically feel the mix of excitement and nerves coursing through the air. As their boot makes contact with the icy surface, it leaves a perfect print behind, a symbol of humanity's expansion into the cosmos. What they see is astonishing. The landscape is both stark and beautiful, with rolling hills of ice and vast plains. The sunlight glints off the frozen surface, creating a dazzling display of colors that dance before their eyes. But it's not just the scenery that captivates them. They're here to investigate, to collect samples, and to search for signs of life. As they explore, the crew begins to take readings. The instruments they've brought along start gathering data, measuring the surface temperature, analyzing the ice, and scanning for any signs of liquid water beneath. Each discovery is a step closer to understanding what lies beneath the surface. And let's not forget the potential for life. Could there be microorganisms living in that hidden ocean? They're not just looking at rocks and ice. They're searching for clues that could answer one of humanity's biggest questions. Are we alone in the universe? That thought fuels their curiosity and determination. As they move further from the ship, the crew splits into teams, carefully communicating with each other through their suits. The sense of teamwork is palpable as they navigate this new terrain, staying in close contact. They share findings, excitement bubbling over with every new piece of data. It's not just a mission, it's a collaborative effort that connects them all. But as they venture deeper, they begin to notice something: changes in the ice. Some areas appear to have been disturbed, as if something has moved beneath the surface. The ice shifts and cracks in ways they hadn't expected. It's both exhilarating and unnerving. What could be causing these disturbances? Are they witnessing geological activity, or is there something else at play? As they discuss their observations, the atmosphere turns serious. They're aware that they're not just explorers, they're scientists on the brink of groundbreaking discoveries. The implications of what they find could change everything we know about life beyond Earth. And with that realization comes a deeper sense of responsibility. As the crew continues their exploration of Europa, the excitement in the air is palpable. They're not just walking on an alien moon, they're stepping into a potential treasure trove of scientific knowledge. With every step they take, they're eager to uncover what's hidden beneath the icy surface. They start by taking samples from the top layer of ice, careful to preserve the integrity of each one. The geologist on the team is particularly enthusiastic. You can see the sparkle in their eyes as they examine the unique formations of the ice. They've studied Europa for years through telescopes and satellites, but nothing compares to standing right here, on the surface. With the samples collected, the crew decides to head towards an area that seems more active, a region where the ice appears to be cracking and shifting. Could this be a sign of geothermal activity? The thought sends a thrill through everyone. If there's warmth beneath the ice, there could be liquid water, and where there's water, there's a chance for life. As they trek across the surface, the landscape changes. They come across a series of fissures in the ice wide enough to peer down into. The team gathers around, peering into the depths. The ice walls glisten like glass and they can see the faint blue glow emanating from below. This is a clue. Maybe the ocean is right beneath them. One of the scientists pulls out a specialized probe designed for just this occasion. They lower it carefully into the fissure, tension hanging in the air. Everyone watches intently, waiting for the data to start streaming in. As it descends, the probe's sensors start to pick up readings, temperature, salinity, even signs of chemical compounds that could suggest biological processes. Every piece of data is a revelation. The crew discusses what it all means, their voices buzzing with excitement. They're realizing that they're not just exploring an icy shell, they're standing above an ocean that could harbor life. It's a game changer, a possibility that has the potential to reshape our understanding of life in the universe. But it's not all smooth sailing. The team's excitement is tempered by the reality of their situation. They're on a distant moon far from home, and they know they have limited time to conduct their research. They've got to be efficient and strategic about how they approach their investigations. Each decision feels significant. Every moment counts. As they continue their exploration, they come across some more unusual formations, ice ridges that look almost like frozen waves. It's stunning, and it's hard not to get caught up in the beauty of the landscape. They take pictures and notes, but there's a pressing need to gather more samples from these areas. What if they discover something that could point to the possibility of life? In one area, they find unusual dark spots on the ice. Curiosity piqued, they approach to take a closer look. It's clear that these spots are different from the surrounding surface. The ice appears to have a different composition. Could these be areas where materials from the ocean below have pushed through? The excitement is infectious as they take samples and prepare them for analysis back on the ship. And let's talk about the sound. Out here, it's eerily quiet. The only noise is the crunch of their boots on the ice and the occasional crackle as the ice shifts beneath them. But even in this silence, there's an underlying hum of anticipation. The crew can feel that they're on the brink of something monumental. With each new finding, they're inching closer to answering the age-old question, is there life beyond Earth? Then comes a pivotal moment. As the team gathers around their samples back at the ship, they start running preliminary analyses. Everyone holds their breath as the data begins to stream in. The results are promising organic compounds, evidence of liquid water, and even signs of potential microbial activity. It's not definitive proof, but it's a tantalizing hint that they're not alone in the universe. The atmosphere in the ship shifts dramatically. They've come to Europa with the hope of making groundbreaking discoveries, and it looks like they might just do it. The excitement is electric as they share their findings with each other. This is the kind of moment every scientist dreams of. A chance to contribute to something larger than themselves. As they wrap up their analysis, the crew can't help but reflect on the enormity of what they're doing. They're part of a legacy, a mission that will inspire future generations. And as they look out at the icy landscape of Europa, they realize that this is just the beginning. There's so much more to explore, so many more secrets waiting to be uncovered. So, with the excitement still buzzing in the air, the crew decides it's time to conduct a more in-depth analysis of the samples they've collected. They set up their portable lab right there on the icy surface, a temporary base camp designed to analyze the data in real time. You can sense the focus in the air as they connect various instruments and prepare to dive into the data. But just as they're about to get started, something unexpected happens. The ground beneath them begins to tremble slightly. At first, it's subtle. just a minor vibration that sends a ripple through the ice. But then, it intensifies, and the crew exchanges nervous glances. Is it a small earthquake? An ice shift? The last thing they want is to be caught off guard on this alien terrain. Quickly, they huddle together, checking their equipment and ensuring everything is secure. The vibrations grow stronger, causing some loose ice to crack and fall away into the abyss below. It's a stark reminder that they're on a moon, where geological activity can occur without warning. The scientists scramble to collect as much data as possible, recording the seismic activity while trying to maintain their composure. Then, just as suddenly as it started, the tremors stop. The silence that follows is deafening, leaving the crew in a state of heightened awareness. They can't shake the feeling that something significant just happened beneath the ice. As they exchange theories, was it a geyser? Some sort of underwater volcanic activity? They realize this could be a pivotal moment in their research. With adrenaline still coursing through their veins, they shift their focus back to the samples. As the lead biologist runs tests on the organic compounds, they notice something peculiar in the readings. One of the samples shows a unique signature, a combination of elements that's unusual for Europa. It raises more questions than it answers. Could this be evidence of life, or is it a product of chemical processes happening below the surface? While the crew is busy analyzing the samples, they decide to take a break and regroup outside the ship. The landscape is breathtaking, a stark contrast to the chaotic energy inside. Standing in the open, they marvel at the ice formations around them, the beauty of this alien world sinking in. It's a moment of calm, a chance to breathe and appreciate where they are. But just as they're soaking it all in, they hear a faint noise, a low rhythmic hum. It's unlike anything they've encountered before. The crew exchanges puzzled looks. Is it natural? Is it coming from the moon itself? Or could it be a sign of something more? Driven by curiosity, they decide to follow the sound, moving cautiously toward its source. The closer they get, the more pronounced it becomes, reverberating through the ice and resonating within them. They feel a sense of urgency, as if they're on the verge of discovering something monumental. As they navigate the icy terrain, they come upon a series of large fissures that seem to pulse with the hum. These cracks are wider and deeper than the others they've encountered, and the sound grows louder as they approach. It's mesmerizing and intimidating all at once, and the crew can't help but feel that they're on the brink of something extraordinary. One of the engineers suggests they set up a sensor to analyze the vibrations, hoping to gain insight into what's happening below. The team works quickly, attaching equipment to the edges of the fissures while keeping a close eye on the readings. What they discover is startling. The vibrations appear to be rhythmic, almost like a heartbeat. It raises the hair on the back of their necks. Could this mean there's some kind of active geological process beneath them? Or could it even be indicative of a biological presence? The thought sends chills down their spines. The excitement is palpable as they gather around the sensor display, monitoring the data in real time. It's an exhilarating moment, but also a sobering one. They realize that this could be a turning point in their mission. If there's something alive down there, it might have implications far beyond their understanding of life in the universe. Just as they're digesting this new information, a surge of energy causes a minor eruption from one of the fissures. A plume of ice and vapor shoots into the air, catching everyone off guard. They step back instinctively, hearts racing as they watch the ice cloud disperse. It's a moment of awe mixed with fear, a powerful reminder of the unpredictable nature of this alien world. The crew stands in stunned silence, processing what they've just witnessed. The excitement in the air shifts to a mixture of caution and wonder. They know they need to document everything, to gather as much data as possible. But there's also a realization that they've crossed a threshold. They're no longer just observers, they're participants in a story that's unfolding in real time, on a world that may hold secrets beyond their wildest dreams. As the crew regains their composure after the unexpected eruption, the excitement is palpable. But so is the weight of what they've just witnessed. This isn't just another data point, it feels like they've stumbled upon something monumental. The realization that they might be standing above an active geological feature, possibly linked to a subsurface ocean, begins to sink in. The lead biologist, still buzzing with adrenaline, gathers the team to discuss their next steps. They know they need to analyze the new data from the eruption. What was that plume composed of? What elements or compounds were released? There's a sense of urgency in the air. Time is of the essence.
They quickly gather their equipment, ready to dive deeper into the analysis, but the atmosphere is thick with unspoken questions. One crew member expresses their concern. What if the activity is a sign of something more complex beneath the surface? They start to discuss the implications of their findings. Could there be a unique ecosystem thriving in the dark waters below? The idea is thrilling yet daunting. If they're right, it could change everything humanity knows about life beyond Earth. With their portable lab set up again, the crew begins to analyze the materials from the eruption.
They take samples from the plume that shot into the air, each one representing a potential breakthrough. There's an infectious excitement in the room as they run tests and eagerly await the results. As the readings begin to come in, the tension builds. At first, the results are promising. They detect organic compounds, traces of salts, and even signs of potential nutrients. But then, the mood shifts slightly when one of the chemists notices something unusual, a compound they didn't expect to find on Europa. It's a combination of elements that typically indicates biological processes. This isn't just a coincidence. It feels like a breadcrumb leading them to something bigger. As the crew absorbs this information, they can't help but wonder if there are organisms living in Europa's ocean. What kind of life could it be? Simple microbes? More complex organisms? The possibilities race through their minds. They discuss what it would mean to discover life on another celestial body. It's a monumental thought, one that could redefine humanity's place in the universe. The ship's communication officer interjects, reminding everyone of the protocol for such discoveries. They need to document everything meticulously, prepare reports for Earth, and establish a plan for further investigation. The crew nods in agreement, but the underlying excitement is undeniable. They're on the cusp of something revolutionary, and it's hard not to let their imaginations run wild. One of the engineers suggests that they should set up additional sensors around the fissures to monitor ongoing activity. They decide to form teams. One group will remain at the original site to continue studying the samples, while another will scout the surrounding area for more evidence of geothermal activity. This mission isn't just about gathering data, it's about exploring the unknown and uncovering the mysteries that Europa has to offer. As they prepare to split up, there's a palpable sense of camaraderie among the team. They're united by their shared purpose and the thrill of discovery. Each member understands the significance of their work and the potential impact it could have on future generations. There's a feeling of being part of something larger than themselves, a collective effort to understand the universe and their place in it. Stepping out again onto the icy surface, the team feels the weight of history on their shoulders. The landscape around them, once alien and intimidating, now feels like a canvas of possibilities. With every step they take, they're not just exploring a new world, they're pushing the boundaries of human knowledge. The team working on the samples is deep in conversation, debating the significance of the readings. They talk about what the next steps might look like. Should they attempt to drill into the ice to reach the ocean below? What would that entail? It's a complex decision, fraught with risks and uncertainties. Meanwhile, the other team ventures further into the surrounding area, their instruments buzzing with anticipation. They scan the landscape for more fissures, more signs of geothermal activity, anything that could hint at what lies beneath. As they move, they can't help but feel a mix of excitement and anxiety. What will they find? What challenges await them? Every crack and crevice they encounter feels charged with potential. They document everything meticulously, taking notes and samples, ready to report back to their teammates. The thrill of exploration is invigorating. They're not just walking on ice, they're on the frontier of discovery, unraveling the secrets of a world that has remained hidden for eons. And then, out of the corner of their eye, one crew member spots something unusual, a shimmering glow emanating from a nearby crack in the ice. It's faint, but it catches their attention. Is it another sign of geothermal activity, or could it be something else entirely? The team gathers, excitement bubbling over as they approach the mysterious glow. The crew gathers around the crack in the ice. The shimmering glow grows more intense. It casts an eerie, almost magical light against the stark white landscape, and the atmosphere is charged with curiosity and anticipation. Everyone's heart races with the thought of what this glow might signify. Could it be an indication of biological activity, or perhaps a unique mineral formation? Carefully, they inch closer to the crack, peering into its depths. The ice walls are translucent, allowing glimpses of the glow dancing beneath. It's mesmerizing. One of the geologists, who can hardly contain their excitement, suggests it could be a bioluminescent organism thriving in the ocean below, adapting to its dark environment. As they lean in closer, the crew uses their cameras to capture the phenomenon, documenting every detail. The biologist starts taking notes, their mind racing with hypotheses. What could be causing the glow? Are these organisms producing light to attract food, or is it a defense mechanism? The questions swirl around them like snowflakes in a storm. One of the engineers, always the practical thinker, suggests they should lower a probe into the crack to gather more information. It's a great idea, but there's a hesitation in the air. This is uncharted territory. They have no way of knowing how deep the crack goes or what might be lurking beneath. But the allure of discovery is too strong to ignore. They carefully set up the probe, attaching it to a long cable. The tension in the air is palpable as they lower it into the crack. Everyone watches closely, breath held, waiting for the first signs of data. The probe begins to descend, its lights illuminating the walls of the fissure, and for a moment, all they see is ice, thick, layered, and seemingly endless.
But then, the probe reaches a certain depth and the glow intensifies, illuminating an underwater landscape that takes their breath away. They can see intricate ice formations and what appears to be a network of channels filled with shimmering liquid. The crew exchanges excited glances. It's like a scene from a sci-fi movie, a breathtaking glimpse of an alien world beneath the ice. As the probe continues its descent, the sensors start picking up readings. The team eagerly gathers around the monitor, watching as data streams in. The temperature is higher than expected, and there's a significant presence of various chemicals, some familiar, others entirely new. The biologist notes the potential for microbial life. This could be a thriving ecosystem just below the surface.
Suddenly the monitor blips and an alert sounds. The probe has detected movement. Everyone leans in closer, eyes wide. What kind of organism could be down there? The excitement is palpable, but there's also a sense of caution. They remind each other that they're in an alien environment where surprises can be both wondrous and dangerous. The probe's camera captures blurry images of shapes moving through the water, darting in and out of view. The crew can't help but gasp. Is it just a reflection, or are there creatures swimming in the liquid below? The biologist scribbles furiously, trying to keep up with the information coming in. The implications of what they're seeing begin to settle in. They might be witnessing life, or at least the remnants of it, in an environment that was once thought to be inhospitable.
As they pull the probe back to the surface, the crew is abuzz with theories and excitement. What they've discovered could change everything about humanity's understanding of life beyond Earth. There's a moment of reflection as they process the gravity of their findings. They're not just explorers anymore. They might be pioneers of a new era in astrobiology. Once the probe is back on solid ground, they gather around it like kids around a campfire, eager to see the images and data it collected. The biologist leads the discussion, analyzing the readings and trying to piece together what they mean. They talk about the potential for more extensive studies, and the possibility of returning with more advanced equipment.
But then, a thought crosses one crew member's mind. If there are organisms thriving down there, could they be intelligent? What kind of civilization could evolve in a dark ocean, isolated from the rest of the universe? The idea is thrilling, yet daunting. They're aware of the ethical implications of their discoveries. If there are living beings beneath the ice, how should they proceed? With the conversation buzzing around them, the team decides they need to formulate a plan. They gather to discuss the next steps, weighing the risks of deeper exploration against the potential rewards. They talk about the need for additional equipment, perhaps even the idea of establishing a more permanent presence on Europa to study these findings in depth. While the excitement of discovery fills the air, there's also a sense of responsibility. They understand that the choices they make now could have long-lasting implications, not only for their mission but for humanity's understanding of life itself. This realization adds a new layer to their exploration, transforming it from mere curiosity to a quest for knowledge that respects the integrity of the unknown. With a renewed sense of purpose, the crew prepares to set their plans in motion. They know they're on the brink of something monumental and the journey is far from over. What lies ahead in the icy depths of Europa? Only time will tell, but one thing is for sure, they are ready to dive in head first. With the excitement of their discovery still fresh, the crew gathers around the probe, buzzing with ideas and theories about their next steps. The biologist takes the lead, suggesting they conduct a comprehensive analysis of the data they've collected. The images from the probe show tantalizing hints of life, and they need to confirm what they've found before proceeding further. Okay everyone, let's focus, the biologist says, adjusting their glasses and pulling up the data on the screen. We have evidence of potential biological activity below the surface. This isn't just a fluke. We need to take this seriously. The engineer nods in agreement. Absolutely. We should think about how we can gather more data without compromising the ecosystem. Maybe we can design a more advanced probe that can withstand the pressure and get deeper into the ocean. Another crew member chimes in, and what about our communication equipment? If we're going deeper, we need to ensure we can transmit data back to the ship and to Earth. We might be working with some groundbreaking findings here. They brainstorm a range of possibilities, each idea building on the last. They discuss the design of new probes, potential drilling methods, and the necessary safety measures to protect their team and the alien environment. The conversation flows freely, energized by the prospect of uncovering more secrets hidden beneath Europa's icy surface. At one point, the geologist raises a crucial question. What if we set up a temporary base camp closer to the fissures? It could allow us to conduct more extensive studies without constantly traveling back to the ship. It would also put us in a better position to observe any changes in activity. Meanwhile, the communications officer reminds everyone of the importance of documenting every step of their process. We need to keep detailed records of our findings and our methods. If we're going to propose a more permanent mission to study this, we need to show how thorough and respectful we are of the environment here. As they debate the idea of a temporary camp, someone suggests conducting a risk assessment. They decide to outline potential hazards of both exploring further and of staying too close to the fissures, thinking through everything from geological instability to contamination of any potential life forms. Then the biologist proposes something that catches everyone off guard. What if we try to communicate with whatever is down there? If there's intelligent life, perhaps there's a way to reach out, to understand it better. The room falls silent for a moment. It's a bold idea, and they all know the implications could be immense. One crew member asks, how would we even do that? If we create sounds or vibrations that mimic their environment, we might elicit a response. It could be a way to gauge the level of complexity of any life forms down there. The engineer perks up at the challenge, suggesting they could use their equipment to create different frequencies and see how the organisms react. It might not be direct communication, but it could give us valuable insights into what we're dealing with. They all get excited about the possibilities, sketching out plans for how they might approach this uncharted territory. The idea of reaching out to potential extraterrestrial life adds a new layer of urgency and thrill to their mission. They realize that if they play their cards right, they might not just be discovering life, they could also be bridging the gap between worlds. As they hash out their strategies, the biologist reminds the crew to prioritize safety and ethics. They all agree. Whatever they find, they must tread carefully and respect the autonomy of whatever lives beneath the ice. This isn't just an expedition, it's a moment in history, and they want to honor the significance of their work. After hours of discussion, they finally settle on a plan. They will start by sending a second probe into the fissure, outfitted with advanced communication capabilities. They'll set up a temporary camp nearby to monitor the environment while conducting their analyses. It's a calculated risk, but the potential rewards are too significant to ignore. With the plan in place, there's a renewed sense of energy in the room. The team is ready to dive deeper into the mysteries of Europa, excited about the discoveries that lie ahead. They gather their equipment, ready to make history and explore the depths of an alien world that has captivated their imaginations and ignited their sense of wonder. As they prepare to set out, there's a shared understanding among the crew. They're not just on a mission for scientific advancement, they're part of something greater, a quest for knowledge that could redefine humanity's understanding of life in the universe. And with every step they take, they're inching closer to uncovering the secrets that Europa holds. With their plan firmly in place, the crew embarks on their next phase of exploration. As they gather their gear, there's an electric sense of anticipation in the air. Everyone is buzzing with excitement about what they might discover, and even a hint of apprehension lingers. After all, they're about to venture into the depths of an alien ocean, a realm where no human has ever set foot. As they make their way to the site of the fissure, the lead engineer double-checks the probe's specifications. Okay everyone, remember our main objectives. We're here to gather more data, conduct our communication experiment, and most importantly, observe without disrupting this ecosystem. The crew nods, their minds racing with possibilities. Upon reaching the fissure, they set up a perimeter to ensure the area remains secure. The biologist leads the charge, instructing everyone on their roles. Let's get the new probe ready to go. I want to ensure we're documenting everything. This is a once-in-a-lifetime opportunity. With everyone in position, they lower the probe into the icy crack, its lights illuminating the darkness like a beacon of hope. The crew watches intently as the device descends deeper into the abyss. The readings start to flow in, and the excitement builds with each new piece of data. Suddenly, the monitor flickers and a new set of images appears. The crew gasps collectively. They can see intricate shapes moving gracefully through the water, small, luminescent creatures dancing in the glow of the probe's lights. It's a breathtaking sight, unlike anything they've ever encountered. The biologist quickly begins analyzing the footage. These organisms are incredible. They seem to have developed a symbiotic relationship with the environment here. Look at how they navigate through the water, almost as if they're using the currents to their advantage. One of the technicians, captivated by the visuals, suggests they send out a series of vibrations to see how the creatures react. Let's see if they respond to different frequencies. If we can understand their behavior, it might give us insight into their communication methods. With that, they adjust the probe's settings, creating low-frequency sounds that ripple through the water. They hold their breath, eagerly awaiting any sign of response. For a moment, nothing happens. Then, slowly but surely, the creatures begin to move toward the probe, drawn in by the vibrations. "Look at that!" the biologist exclaims. "They're responding! This is astonishing!" The crew watches in awe as the creatures gather around the probe, their bioluminescent bodies glowing more brightly in the presence of the sounds. As the team collects data, the engineer suggests a bold idea. What if we try to establish a pattern? If we can create a series of sounds that the creatures recognize, we might just get a clearer response. Everyone agrees that it's worth a shot. They begin to experiment with different sequences of sounds, mixing pitches and rhythms to see what resonates. Time seems to slip away as they work, fully immersed in the moment. Each sound they produce elicits a different reaction, and they marvel at how the creatures seem to mimic the patterns back to them. There's a growing realization among the crew. They may be witnessing a form of communication. The thrill of discovery reaches new heights as they contemplate the implications of what they're experiencing. Suddenly, an unexpected occurrence catches their attention. One of the creatures, larger and more vibrant than the rest, moves closer to the probe. It pauses, seemingly studying the device. The crew's hearts race. Could this be a sign of intelligence? The biologist leans closer to the monitor, captivated. If we can establish a connection with this one, it could lead to incredible insights about the entire ecosystem. We need to be careful though, we don't want to overwhelm it. With that in mind, they decide to reduce the sound levels, opting for soft, gentle vibrations. The atmosphere is charged with tension as they wait, holding their breaths in anticipation. The creature moves even closer, its luminescence pulsating in a rhythmic pattern, almost as if it's mirroring the probe's signals. As the interaction unfolds, the crew is filled with a mixture of exhilaration and caution. What if this creature is a gateway to understanding an entirely new form of life? The excitement is palpable and they can hardly believe what they're witnessing. In this moment, the enormity of their mission becomes crystal clear. They're not just here to explore, they're on the cusp of a monumental breakthrough in understanding life beyond Earth. With every sound, every response, they're unraveling the mysteries of Europa, one interaction at a time. And just as they begin to feel a sense of connection with the creature, the probe picks up an unusual reading. Something big is shifting beneath the surface. The monitor lights up with alarms, and the crew exchanges worried glances. What could it be? Are they in danger, or is something extraordinary about to happen? The excitement turns into a rush of adrenaline as they prepare for whatever comes next. They're poised on the brink of discovery, ready to dive deeper into the unknown, even as the icy world around them starts to change in ways they never expected.